The ASUS TUF FX505 gaming laptop has some pretty nice hardware, but just how hot does it get, and is there any throttling? If you saw my previous FX504 review, there was some serious throttling taking place. So let's find out if this has been fixed with the newer FX505. In my configuration here, I've got the Intel i7-8750H CPU with NVIDIA GTX 1060 graphics. Thermal testing was completed with an ambient room temperature of 22 degrees Celsius, so expect warmer temperatures in a warmer environment. Also keep in mind there are heat pipes shared between the processor and graphics, so a change in one component may affect the other. Like other ASUS laptops, this one also lets you pick between silent, balanced, and overboost modes. These are built-in profiles that increase performance at the cost of boosting fan speed and CPU TDP, and I've done my testing with all three. Starting at the bottom of the graph, at idle the temperatures are fairly cool with silent mode, shown by the light blue bars. The gaming tests were done with Watch Dogs 2, as I find it to use a good combination of CPU and GPU. Continuing up in the green bar with balanced mode, we're seeing the hottest temperatures while gaming, and the temperatures drop down by around 5 degrees Celsius with overboost mode enabled, as this maxes out the fans, shown by the yellow bar. With balanced mode and a minus 0.150 volt undervolt applied to the CPU, shown in the orange bar, the temperatures are a fair bit better. And when combining the undervolt with the faster fan speeds in overboost mode, shown in red, we're actually getting fairly cool temperatures. The stress tests were done by running ASUS and the Heaven benchmark at the same time, in order to attempt to fully utilize both the processor and graphics. Moving up in the graph and continuing with the dark red bar, with balanced mode there was a 35 watt limit on the TDP, so power limit throttling was taking place with the CPU on 90 degrees. With overboost mode enabled in pink, the active TDP rose to 45 watts. There was still power limit throttling, but also thermal throttling now, despite the increased fan speed, as the TDP boost is adding more heat. In the purple bar with balanced mode and the CPU undervolted, there was no difference in temperature, but we'll see the performance differences in the next graph. The dark blue bar shows overboost mode with the CPU undervolt applied, and there was still thermal throttling here. For the first time, I've also tested using a cooling pad, shown by the black bar up the top, and I was only seeing a very minor change. These are the average clock speeds for the same tests just shown. Again, starting down the bottom, we can see that with overboost mode enabled in yellow, the CPU clock speed rises as the TDP gets boosted. Interestingly, with my undervolt applied, the clock speed dropped down a bit. I'm suspecting because it may not have been getting enough power, although I did try lower undervolts and the result didn't really change. And this didn't seem to be an issue with the stress tests. Moving up to the stress tests, we can see that with overboost mode and the CPU undervolt applied, we're extremely close to the full 3.9 GHz all-core turbo speed of the 8750H. An impressive result under a combined CPU and GPU stress test. And again, no real difference with the cooling pad shown in black. These are the clock speeds I got while just running CPU-only stress tests without any GPU load. As mentioned, there are three built-in profiles on the laptop called Silent, Balanced, and Overboost. With the ASUS stress test running, I found these profiles to limit the CPU to 33 watts in Silent, 38 watts in Balanced, and then the full 45 watt TDP in Overboost mode. We're only able to reach the full 3.9 GHz turbo boost speed on all cores under stress test with overboost mode while undervolted, as shown in the top red bar. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here, with the older 7th gen i7-7700HQ just down the bottom for comparison. With a silent profile, the laptop is quieter, but as shown, this restricts performance. Though interestingly, while undervolted in silent mode, we can get better performance than overboost mode without undervolting, which runs much louder too. With a combination of overboost mode and undervolting, we can get the full performance of the i7-8750H. Otherwise, this was not possible prior to undervolting in my unit. Here are the GPU-only clock speeds, while under a graphical-only stress test, both at stock and with a 500 MHz GPU core overclock applied. Although on average in this test, we're seeing a 150 MHz boost due to power limitations on the graphics, and I wasn't able to modify this with MSI's Afterburner. So how does this performance boost actually translate into games? I've tested with the exact same Windows, Nvidia, and game updates installed. The only changes were the ones listed here. Far Cry 5 was tested using the built-in benchmark. The average frame rates at ultra settings were 5.9% better compared to stock speeds, although the changes to the 1% low seem to vary based on the settings. So we are able to get a nice little boost to performance with a combination of CPU undervolting and graphics overclocking. However, this will of course vary between games. As for the external temperatures where you'll actually be putting your hands, at idle 15 minutes after completing stress tests it was around 30 degrees, though up to 40 near the center. While gaming, the center gets to around 50 degrees Celsius, but the rest is quite cool in comparison. And then a similar result was seen with the CPU and GPU stress tests running. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle, the fan was still audible, even with the silent profile enabled. While gaming and under stress test, it was about the same, and around the same volume as most other gaming laptops I've tested, and then just a little louder with overboost mode and the fans maxed out. Overall, the performance was pretty good for an 8th gen i7 8750H laptop. We're pretty much able to get full performance out of the CPU, even under a combined CPU and GPU only stress test. Although this did require a combination of overboost mode and undervolting to achieve. And it was still quite warm during this worst case scenario. This is a huge improvement when compared to the previous ASUS FX504, which capped the CPU to a 25W TDP and resulted in poor performance and stuttering in games. There are more heat pipes here in the FX505, which also appear to be thicker, so it's better equipped to dissipate the extra heat from the higher TDP limit. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements. So don't just blindly copy my settings, and do some testing to find out where your stable point is for best results. While you could probably improve the temperatures by swapping out the thermal paste, that's not something I can test in a review unit. If I go ahead and remove the stock thermal paste and replace my own, I can't put the old paste back. So the next reviewer would experience something different from what you'd actually see with the product and unknowingly report incorrect information due to what I've done. Undervolting and raising the fan speed on the other hand aren't physically intrusive. And as we've seen, it did improve temperatures and gaming performance a little in this particular unit, with no downside once you've got a stable undervolt. And as we saw, a cooling pad can also help a little, but my particular one didn't make much of a difference. Let me know how much of a performance boost you've found by undervolting your hardware, and what you thought of the improvements here. And don't forget to subscribe for the full review of the ASUS TUF FX505 gaming laptop, as well as future tech videos like this one.